Hello once again, this is John. I'm going to be taking you through the Teaching Long Multiplication presentation today. So let's get started. Now, why bother looking at such a simple idea? Well, firstly, just like with negative numbers, it's something they meet at Key Stage 2. So it's clearly an important topic. There is also a big push going on at the moment to include more arithmetic problems in the new GCSE syllabus. That's really linking in with this new idea of including more functional skills questions or more problem solving questions. So apparently they're going to be implementing a policy in the new curriculum of asking more questions which apply to real life situations. Questions like, I've got to decorate a bathroom. They might give you the dimensions of the wall. They might give you the dimensions of a certain tile which is for sale in a hardware store. And they might ask you how many tiles you need to tile the wall. This question could naturally be followed with what is the cost of the tiles, and clearly they're going to need long multiplication there. Now, what you need to be aware of when you teach long multiplication is that there are in fact many different ways of performing this task. I'm sure many of you are already aware of this. Some of these approaches, though, can look quite unusual to the untrained eye, and that's why I want to take you through at least 5 different ways of doing long multiplication. I want to say straight away that only 3 of these I consider efficient algorithms for doing long multiplication. The last 2 I'm showing you, well, really it's just for fun. But it's still worth looking at because you never know, some students might mention it in a lesson, and the beauty of the last 2 algorithms is that they can be done without knowing any of your times tables, which is really quite amazing. Okay, one last thing I'd like to point out is teaching many methods for doing long multiplication is actually surprisingly controversial in the classroom. I've heard of lots of different mathematics departments actually having an official policy on how to teach long multiplication and sticking to just one of these methods. Now, I'm not a big fan of that kind of approach. I think that if the students have a valid approach to doing long multiplication and they understand it, why should I try and convince them to do it in another way? If they've got a method which works, even if it does seem to me to take a little bit longer, I don't like to stop them. If it's a really inefficient method, I might show them why I think it's a poor approach, but I think it's a good idea to let your students go their own way in mathematics, and it's up to you as a teacher to understand all the methods that they might use. Okay, so without further ado, let's take a look at some of these methods. The first approach is the one I expect you all know and love. I'm calling it the standard approach here. It is column long multiplication. Now, even within the standard approach, we have differences of opinion about where you should show the carry numbers. So you'll notice on my calculation on the left, the carry of 2 is done below the line, whereas on my calculation on the right, the carry of 4 is done above the line. It is not unusual for primary schools now to teach the number carry to be put above the number rather than below. The reasoning behind that I'm uncertain of. Obviously it really changes nothing at all. So nothing to worry about there, and I'm sure you know this approach very well. Now let's talk about its advantages and disadvantages. It's arguably the most efficient out of the 3 methods I'm going to show you initially. It's almost certainly the most widely used and taught, in my opinion, in this country, and it's reasonably easy to understand what you're doing and why. What I mean by that is obviously when you're doing 327 times 53, for example, you're going to do 3 7s, 3 20s and 3 300s, and that's essentially what you're doing in the first line. And then you write a 0 down on the second line because you're not really doing 5 times 7, you're really doing 50 times 7, 50 times 20 and 50 times 300, and the 0 takes care of that. So reasonably straightforward to understand. The disadvantages are that it is difficult to relate to algebraic multiplication. Now what I mean by that is, if you're expanding a pair of brackets when you're dealing with a quadratic expression, you can't really see any kind of similarities between that and method 1. So that is, I think, a disadvantage. With that, I'm going to go on to method 2. Now you may have seen this method before, and it is certainly, out of the 3 methods I'm showing you today, it's my favourite method. Now I would like to point out that I am alone in the department that I work in preferring this method out of the 3. Most of my colleagues prefer method 1. But the reason I prefer method 2, which is a grid multiplication, well, it's because it looks extremely similar. In fact, it's exactly the same as the way we multiply out a pair of brackets in with quadratic expressions. And so I can link the two, which I really like. Now, I'm pretty sure that most of you will have seen this method before, and even if you've never seen it before, I'm certain you'll immediately understand it, because this is one of its advantages. I think it's even easier to follow the method and understand why it works. It's widely taught in primary schools now as well. I think a lot of primary schools are coming round to this way of doing things. And like I say, it's very easy to relate to FOIL. Now you'll see that acronym, if you've never seen that acronym before. It just means first, outer, inner, last. It's a way of describing how students multiply out brackets. I must admit I don't use FOIL much when I'm explaining it, because I just show them it in a grid and I just explain that that's exactly the same as how I do long multiplication. What I like about that is I can say things like, if I want to multiply very quickly in my head 49 times 51, what I'm really doing there is x plus 1 times x minus 1, with x taking the value of 50. So as I know that x plus 1 times x minus 1 in brackets is x squared minus 1, if I want to do 49 times 51, all I have to do is let x be 50 and then do 50 squared minus 1, which is of course 2499. There we go, I've done 49 times 51 very quickly in my head. And I've managed to relate it quite nicely to the way we multiply out brackets, and yes, it's exactly the same as the way we multiply out numbers. The disadvantages, of course, are that it's slower to achieve the same result. And that is, a little bit of a drawback, there's no doubt about it. Anyway, this takes us on to method 3, which certainly when I started teaching, I'd never seen it before, and the very first time I saw it, I was honestly really impressed. It's sometimes called the lattice method, or occasionally Napier's method, or even Napier's bones, and it involves you drawing this little grid up, but also drawing diagonal lines across the grid. Now, if you just look at what's going on, I'm sure you'll see exactly what's going on. Quite simply, we're doing 6 times 4 and putting the answer 24 with the 2, the tens on the left-hand side and the units on the right. Then we're doing 5 times 4, same thing. 8 times 4, same thing. All the way across, and the same for all the calculations along the bottom row. All they've got to do at the end, the students, is simply add across the diagonal. Now, you still must make sure that you start with the diagonal on the bottom right-hand side, the 6, then add up the 2, 5 and 5, making 12. You'll need to carry that one over into the next diagonal. It's essentially working very, very similar to method 1 from that point, really, where you add things up at the end. But there's something really quite nice and neat about this method. It really is quite clever, quite nice, quite snazzy. So, once again, I was really impressed when I saw a student do it like that, and yeah, I'd learned something that day, a new way of doing long multiplication. Okay, yes, really, it's the same as the other methods, but look out for that one. It's rarely spotted, but you might actually occasionally see it, and if they're using it, fair enough. If they're using it successfully, it's not a bad way, not a bad approach. Advantages: easy to follow once again, surprisingly efficient, quite easy to understand what's going on, but once again, the disadvantage, like with method 1, is that it's difficult to relate to algebraic manipulation. Now, this is the reason why, when I look at all three of these methods, I'm a big fan of the grid method. And I can show you some questions which are really very advanced questions, where if students are happy with the grid method multiplication, they can actually do some really clever things later on in some of the extension papers at the end of A-level, like step papers or whatever. If you're a fan of the grid method, it makes division of certain polynomials really straightforward, and you don't have to do the long division method, which is actually quite confusing in some ways. So for much later in their education, the grid method, I think, is actually really useful. But that's just my opinion. You may lean towards any one of these methods in your teaching, and you may decide to teach any one of those methods. You may well work in a department where they insist on you teaching a certain method. But I would always say to you, if a student does use an alternative approach, and they use it very well, why stop them doing that? That's absolutely fine. Okay, now I'm going to go on to a couple more methods, which are just a bit of fun really, to show how long multiplication could actually take a very long time, but you can do it without knowing any of your times tables, which is really quite remarkable really. So let's move on to the fourth method I'm going to show you, which is sometimes called the Russian peasant's algorithm. Now, so the story goes, Russian peasants, I guess, aren't so good at learning their times tables, but they are very good at halving and doubling numbers, and also adding numbers. Now, providing you can halve and double and add, and follow this simple set of rules, you can actually multiply anything you like together, whether it's 2-digit by 2-digit, 3-digit by 3-digit, so on and so forth. Now, the rules are quite simple. You have to set up two columns, put in the small number on the left hand side and the larger number on the right hand side. So as you can see, they've got 37 times 56. Now each row down beneath that top row there, you need to halve the one on the left and double the one on the right. If the one on the left is odd, halve it and round down, if you see what I mean, to the nearest integer. So half of 37 is 18.5, we round that down to 18. We double 56 though, and we make 112. We keep doing that till we get to 1 on the left hand side and whatever we might have on the right hand side. And at that point, we take stock of what we've got. We look at every single row and we highlight every single row which has odd numbers in the left hand column. So looking down all 6 of those rows, I can see we've got 37, 9 and 1 as our odd numbers in the left hand column. In the right hand column you'll have at most one odd number at the start because you're doubling it each time, so it's just the left hand column where you might have some odd numbers. Now those particular ones, highlight those rows and now look at the right hand number and add up all the right hand numbers in the right hand column which had an odd counterpart on the left hand side. So those are the numbers 56, 224 and 1792. Add those values up and you've got the result of 37 times 56, which I think actually is incredible, really quite amazing. I've never actually sat about and tried to prove that this method always works, and I'm still shocked that it does, because I'm not too sure I understand how it works, but it definitely does work each time. It actually pops up in AS Maths if they do a very obscure module called Decision Maths. It's sometimes mentioned in some of the textbooks anyway, and it's a good little thing to give a class, a good little algorithm to give a class. If you want to get them used to just following a set of instructions, a set of rules in maths, give them that without showing them the example and watch them just apply a set of rules. They'll find it surprisingly difficult because following a set of instructions is actually much harder than it looks if you haven't got an example. I mean, we have an example here, it's much easier for us, but it's surprisingly difficult to do, and so it can be a nice little extension activity for a class which is really quite sharp, maybe in year 11, but certainly in year 12 if you're doing decision maths module where you have to do algorithms. It's a good algorithm to test them. But what I find incredible about that algorithm is I don't need to know any of my times tables and I can do long multiplication. Okay, that takes us nicely to the very last algorithm, which I'm going to show you. This is actually the end of the presentation because I'd like you to just watch the Chinese line multiplication, which is beautifully shown in this YouTube clip. It's similar to the Russian peasants algorithm in that you don't need to know your times tables. And once again, it looks amazing and incredible until you consider how long it takes, particularly to do the multiplication of certain numbers. See if you can decide which numbers they are. But I hope you enjoy the video for Chinese line multiplication, and I hope you've enjoyed this little chat about all the different methods there are for long multiplication, and I hope it's been useful. But just be aware there's many different approaches to long multiplication, and I know it might feel like we're reinventing the wheel here for you. Well, use whichever approach you're most comfortable with, but be aware that the students might choose to use a different method. Okay, that completes the presentation. I hope you enjoyed it and found it useful. Bye bye.